In this video, we're going to talk about completing the square. The inverse operation of squaring something is square rooting it. We're going to talk about the simplest type of quadratic equations where we're going to use this inverse operation of square rooting to solve. It's ax squared is equal to c. If you have quadratic equations where b in ax squared plus bx plus c is 0. That means there's no b term. There's an a, there's a c, but no b. There is another way of going about solving this quadratic equation. In order to solve a, 4x squared plus 10 equals 46, if you think about the problem like you do any other equation, like pretend like that square isn't there. You would probably say to yourself, well, I'm going to subtract 10 from both sides, and then I'm going to divide by 4. It's just that the answer is not going to be 9, because x squared is equal to 9. So in order to finish this problem off, we're going to do the inverse operation of squaring, which is square rooting. Now, here's the kicker, though. When you take the square root of 9, yes, it is 3, but we're going to write plus or minus in front of it. There are actually two answers. One of them is positive 3 and the other is minus 3. The reason that happens is if you go back and look at the quadratic equation, x equals the opposite of b plus or minus the square root of b squared minus 4ac. By the way, c would be negative 36 if you went and put this in standard form, all over 2a. You would end up with plus or minus the square root of 576, and the square root of 576 is 24. So you get plus or minus 24 over 8, which is plus or minus 3. So the reason that there's actually a plus or minus sign there, even though we normally say the square root of 9 is 3, is because if we actually use the quadratic equation would result in that plus or minus sign. It's just that the way we did it the first time is a lot faster than the quadratic equation for these types of equations. All right, let's look at b. 3x squared minus 5 equals 25. If you pretend like it's any other linear equation, you would probably say to yourself, well, I'm going to add 5. And then I'm going to divide by 3. It's just you're left with x squared is equal to 10. So when you square root both sides, you're going to say x is equal to plus or minus the square root of 10. And since the square root of 10 is not an integer, we're going to leave it as the square root of 10, so we leave it as an exact answer. Now on your own, you're going to try to solve these two equations. 7x squared minus 10 equals 25, and 2x squared plus 9 equals 13. In problem 2, this is an architecture problem. It says, while designing a house, an architect used windows like the ones shown here. What are the dimensions of the window if it has 2,766 square inches of glass? All right, so in order to find the dimensions of the window, that means we want to find the length and the width of the rectangular window, but the top part of the window is a semicircle. It's half a circle. And so we probably want to know what the radius of that circle is. Now, because they told me that we're using 2,766 square inches of glass, square inches, also written like this, is a unit of area. So because it's a unit of area, that means I'm going to use the area formulas for a rectangle and a circle in order to write an equation to solve. So let's start with this. Let's start with the area of the rectangle. Well, the formula for the area of a rectangle is length times width. So in this case, it's 2x times x, which is 2x squared. The semicircle is going to take a little bit more work because you have to start with what's the formula for the area of a circle. Well, the area of a circle is pi r squared, except that we don't have a whole circle, we have half a circle. So we're going to divide that by 2. Now the next question is, what's the radius of that circle? Well, the radius is half of that length. Well, if the entire length of the diameter is x, then the radius must be half of that, or x over 2. So it's going to be, I'm going to separate this a little. I'm going to write this as pi over 2 times r squared. It just makes it a little bit easier for simplifying. So x over 2, when you square it, is going to be x squared over 4. Because you square the top and you square the bottom. That's the easiest way to square a fraction. Now I'm going to multiply pi over 2 times x over 4, and I'm going to get pi times x over 8. So now I know the area of the rectangle, I know the area of the semicircle. The total area must be the sum of those two. So it's 2x squared, oops, I forgot my square there, plus pi x squared over 8. And that's going to equal 2,766. All right. What am I going to do next? Well, I want you to notice that these two terms share a common factor. They both have an x squared. So if you take an x squared away from both of them, you're left with this. Matter of fact, if it makes you feel better, you can turn this into a decimal in order to finish the problem off. So I'm going to put into my calculator 2 plus, there is a pi function on the graphing calculator. It's the second function over the caret key, or the key that you would use to raise a number to a power. And it turns out that 2 plus pi over 8 is approximately 2.39, because we like to round things to the nearest hundredth. Now I'm going to divide 2766 by 2.39. And I'm going to find out that x squared is approximately equal to 1,157.32. And then I'm going to square root both sides. And the square root of 1,157.32 is approximately 34. Now here's the thing. I write plus or minus 34, but does negative 34 make sense in this type of problem? We're talking about the length and width of a rectangle. Can length or width be negative? No. So it turns out that negative 34 is not a reasonable answer for this particular problem. So we just say that it's positive 34. Therefore, the dimensions must be, well, one side of the rectangle is 34, and the other side is 2 times 34, which is 68. So those are the dimensions of the rectangle. Well, how about the dimensions of the semicircle? Well, if the diameter of the semicircle is 34, then the radius must be half of that, or 17. Now on your own, I want you to do this example. The lengths of the sides of a rectangular window have the ratio 1.6 to 1. The area of the window is 2,822.4 square inches. What are the window dimensions? Hint, draw a picture. Whenever you have something that says it's in the ratio of something to something, you're going to stick little x's next to it. So basically it says one side is 1.6x and the other side is x. How do you find the area of a rectangle? if you can set up that equation for this problem, you'll be able to solve for x. What we're going to learn to do is to work with these things called perfect square trinomials. We've talked about these before. Perfect square trinomials are ones where the last term is a number times itself, and the middle term is that same number plus itself. The thing about perfect square trinomials is if you graph them on the calculator, they only hit the x-axis at one location. To factor them, you just take the square root of the first term, the square root of the last term, and the sign between them is always the sign on the middle number. So if I factor that perfect square trinomial, and then I go and solve it, and I take the square root of both sides, I'm going to be left with x plus 2 is equal to plus or minus 5. Don't forget that plus or minus sign when you do the square root. So there are two equations. One of them is x plus 2 equals 5, and the other one is x plus 2 equals negative 5. So x is equal to 3, and x is equal to negative 7. Now, solving this using completing the square is not, we haven't even talked about how to complete a square yet, but factoring a perfect square trinomial and then using the square root function to solve is just another way of solving this quadratic equation. Would it have been easier for you to set the equation equal to 0 and graph it and find where it hits the x-axis? Yeah, probably. Would you have been happier using the quadratic formula? Possibly. But this will come back to haunt you in pre-calculus. So we talk about exposure to things, and this is you being exposed to this type of problem. There is nothing in this problem that you have not done before. Now on your own, I want you to try this example. X squared minus 14x plus 49 equals 25. I claim to you that this is a perfect square trinomial, so all you have to do is factor it, like I did in the previous problem. Square root both sides. Don't forget the plus or minus sign. And then find the two solutions.